Hi class, this is a section on zeros of polynomials. So they start us off with the fundamental theorem of algebra, which says that if a polynomial f of x has a positive degree, that means non-zero and non-negative, and complex coefficients, then the function has at least one complex zero. All right, let's see, the complete factorization theorem of polynomials says that if you have a polynomial f of x and if the degree is greater than 0, then there exist n complex numbers c sub 1 through c sub n such that you can factor your polynomial into n different factors. All right, and then the next theorem says that the maximum number of zeros of a polynomial is n. So it can't have more than n zeros if the degree is n. So for example, if it's degree 5, then at most there will be 5 different complex zeros. If the degree is 4, then at most there will be 4 different complex zeros. So let's look at the first example. Find a polynomial f of x in factored form that has degree 3. So at most, there will be 3 zeros. All right, and they give them to us. It's 2, -1, and 3. And then they give you a condition that needs to be satisfied. This will allow us to figure out what a has to be. As you can see, that leading coefficient is a. This additional given information will allow us to solve for a. So let's write these 3 zeros in factored form. So the first one would be written as x minus 2, because if you set that equal to 0 and solve, you're going to get x equals 2. The second factor can be written as x plus 1. Same thing, if you set that equal to 0 and solve, you'll get -1, which is the 0. And the last one can be written as x minus 3. And we don't know what a is, so we'll leave that as a, and your function is f of x. So this is what we have. Now we can enter the given information to figure out what a has to be. So when x is 1, the function is equal to 5. So the function will be equal to 5 when x is 1. So now we can solve for a. So this will be 5 equals a times -1 times 2 times -1. So that means that we have, what is that? That's going to be 2a equals 5, which means a equals 5 over 2. So our final polynomial would be f of x equals 5 over 2, x minus 2, x plus 1, and x minus 3. You can leave our answer in factored form unless they specify that they want you to multiply it out, which they don't say. They actually say find a polynomial in factored form. This is factored form, so you wouldn't need to multiply that out. I'll highlight that for emphasis. All right, the next example says, find the zeros of the polynomial, state the multiplicity of each, and then sketch the graph. So to find the zeros, that means we set the function equal to 0, and then factor it. So we can factor this by taking out the GCF. The GCF is x to the third. That'll leave us with 16x squared minus 40x plus 25. And because this is a perfect square and this is a perfect square, this is going to be able to factor into 4x times 4x and -5 times -5. The reason it's negative times a negative is because you need the middle term to be -40. If this were a plus 40, then these would be plus 5 plus 5. So your factors should look like this. X cubed, 4x minus 5, and 4x minus 5, which can be written as 4x minus 5 to the second power. All right, so now that we've factored that polynomial, now we can find the zeros and the multiplicity. So the zeros are given by, this one is x cubed equals 0. This was 4x minus 5 equals 0. Actually, you don't need the exponent for this. So this one is already solved. This one would be, if you solve for x, you would get 5 over 4. So we found the 2 zeros, but there's multiplicity here that we need to consider. This 0 has multiplicity 3. Because of the exponent. The exponent tells you the multiplicity. So this 0 has multiplicity 3. This 0 has multiplicity 2. So I'll write that over here, multiplicity 2. Okay, so let's talk about multiplicity and what that means. So let's go over here to a new page. So if the multiplicity is odd versus multiplicity even. All right, so if you have an odd multiplicity, I'll show you what that can look like. So let's say you had a 0 right there. So odd means if the multiplicity is 1, then it's just going to go right through the 0. It's going to go through the 0. If the multiplicity is odd but greater than 1, so for example 3 or 5 or 7, so on and so on, then your graph will look like this. Let's say you had a 0 here. It's still going to go through, except it's going to do this little kind of curve. Before it goes through the 0, it's going to curve and then go through it. So that's for higher odd multiplicities. If it's just 1, then it just goes directly through without curving, like this does. All right, so for even multiplicity, let's say, for example, multiplicity 2 or 4. 2 or 4, for example, let's say this is a 0, then your graph is actually just going to touch and turn. It's not going to go through the axis. It's going to simply touch and turn. All right, so that's that's the information you would need to know. So now going back to this problem, so we have 2 zeros. So let's graph those, one at 0 and the other one at 5/4, which would be 1.25 right there, approximately. This one has an odd multiplicity. It's multiplicity 3. So like we said, it's going to go through, but it's going to curve like that. Or it could go from the top, depending on whether it's positive in this interval or negative. So I'm going to test -1 to see if it's positive or negative. So if you plug in -1 into this function here, this is going to be negative, and this is going to be positive because of the square. So you have a negative times a positive, which is a negative. So that means our graph has to come from the bottom, and then it's got to go through, but it's got to curve. And then this is multiplicity 2, so it's got to touch and turn because it's multiplicity 2, which is even. So that's what our graph is going to look like. It's going to start here and go curve through, touch and turn, and continue to go up. All right, and that pretty much does it for that. You could confirm your answer by using a graphing calculator, or if you don't have a graphing calculator, you can go to www.desmos.com, and you can enter this graph. You can enter y equals x cubed for x minus 5 squared, or you can just enter the non-factored version if you want, the original function. You can enter any of the two versions, factored or non-factored, into desmos.com, and that'll confirm that your graph does indeed look like this. All right. All right, for this next example, it says, show that -2 of multiplicity 3 is a 0 of the function and express the function as a product of linear functions. All right, so the easiest way to show that -2 is a 0 is by doing synthetic division. So let's do -2 synthetic division, upper left corner. The coefficients are 1, 5, 6, -4, -8. Just make sure that there's no missing terms. 4, 3, 2, 1, 0. So there's no missing terms. We draw our straight line. We bring down the first term, and we multiply, add, multiply, add, multiply, add, multiply, add. As you can see, the remainder is 0, which means that -2 is a 0 of the function. So we've confirmed it for the first multiplicity. Now let's confirm it for the second multiplicity, which means we can repeat that process again with the same 0. And we use these now as your new coefficients. So we bring the first term down again. And then we multiply, add, multiply, add, multiply, add. And you will see that again, we get remainder 0 again, which means that this is a 0 again for the second time. So now we have multiplicity 2. And it says that they want us to confirm that it's got multiplicity 3, so we repeat that process one final time. Bring down the 1. Multiply, we get -2, add -1, multiply 2, add, you get 0. So the remainder is 0 once again, and that confirms that -2 is a 0 with multiplicity 3. All right, so the final 0 will be given by this remaining polynomial. This quotient here is x minus 1. So x minus 1 has a 0 of 1. So now we've gotten the 4 zeros, and I know that there's 4 zeros at most because of the degree. The degree is 4, which means at most there will be 4 zeros, which there are in this case. So once again, the way I got this 0 is from this quotient. This is your constant term, this is your x term, so it's x minus 1, and I set that equal to 0 in order to solve. So the final answer would be f of x is equal to x minus 1, x plus 2 to the third power. This is the factor for this 0, multiplicity 1, and the factor to the -2, 0 is given by x plus 2, and since it has multiplicity 3, it has to be to the third power. That is the final answer. And they did want this function as a product of linear factors. So this is a linear factor, because there's 3 of them. So this is the way you should write your final answer. All right, the final thing that we're going to cover in this section is Descartes' rule of signs. So you can read through this. I think it's a little bit easier if I just explain it through this example here. But we do need to do 2 things. So to check for the number of positive real zeros of f of x, we need to count the number of variations of the sign of f of x, or is less than that by a number of an even integer. So that's a little confusing. So let me tell you what they're doing here. So we have our function 3x4 plus 2x cubed minus 4x plus 2. You want to count the number of times that the sign varies. So it goes from positive to positive, so that's 0 so far. And then it goes from positive to negative, that's 1 sign change. And then from negative to positive, that's another sign change. So there are 2 sign changes. All right, so the number of positive real zeros is either 2 or is less than that by an even number. Well, the only even number that you can subtract would be 2. So it's either going to be 2. So the number of positive real zeros is 2, or if you subtract 2, is 0. And I'm getting 0 because I'm subtracting 2 from the number of sign changes, which gives us 0. The reason I'm subtracting 2 is because it says here, or is less than that by an even integer. So you can subtract an even integer from 2, and if you subtract 2 minus 2, you get 0. So this is what the number of possible positive real zeros are, either 2 or 0. And then we do the same thing for negative. However, we have to substitute negative x into the function first, and then count the number of variations in sign. So let's do that. F of negative x is going to be so this becomes negative x to the 4th is just x to the 4th. This will become negative 2x cubed. This will become positive 4x, and this is plus 2. So let's count the number of variations in sign. So from here to here, that's one variation. From here to here, that's another variation. And from here to here, that's not a variation because it's going from positive to positive. So this one's going to be similar. There are two sign changes. That means that the possible number of negative real zeros is 2 or 0 again. So now we can discuss, it says discuss the number of possible positive and negative real numbers and imaginary solutions as well. So possible positive, possible negative, and possible imaginary solutions. So as a summary, I recommend that you do a table like this. So possible positive, possible negative, and possible imaginary, and then the total. So we can create a box here, or a table, to organize our information. I'm not sure how long it's going to be, so I'm just going to make it an arbitrary length. All right, so for the first one, the number of possible positive values are 2 or 0, so I would write 2 here. And I know that the total number of zeros is 4 because of the degree, so the total has to be 4. All right, and then in order for the total to be 4, this column has to add up to 4. So we have 2, and negative possible would be 2 as well, which means that this would have to be 0. The other possibility is that this is 2 again. This is 0 because it can be 0 as well, and that would mean that there would have to be 2 imaginary in order for the total to be 4 again. And then the other possibility is that there are 0 positive zeros, and that means maybe 2 negative. And that would mean that there would have to be 2 imaginary in order for it to total up to 4. And then the last case would be if there are 0 positive, 0 negative, which is possible, 0, 0, which means there would have to be 4 imaginary solutions in order for the total to be 4. So this is the way I would recommend that you organize your final answer. So the number of possible positive zeros are 2, 2, or 0. Negative would be 2, 0, 2, 0. And imaginary 0, 2, 2, 4. All right.